Welcome everyone. Today I'll discuss about the topic continuity. Continuity. It is a chapter of differential calculus and it is fully based on concept of limit. It is actually application of limit. To solve problem of continuity, you should have idea about limit. So continuity of a function. So continuity of a function. Look at the figure 1. AB is a curve. We do not know the form of fx. It may be straight line or any curve. AB. Look at the nature of the curve. Look, the curve can be drawn without lifting the pen. It has no break point. So, in figure 2, so look, the curve, it has a break point at C. So, if it can be sketched without lifting the pen, then we can say it is continuous. And look, it has break point. So this is rough definition. So what is rough definition? Roughly speaking, graph of a function is said to be continuous. Is said to be continuous if it can be sketched without lifting the pen. Without lifting the pen or pencil, without lifting the pen. That is, it has no break point. In figure 1, AB is continuous curve. So this is idea from graph. Look, it can be sketched without lifting the pen. That is, it has no break point. Now in figure 2, it has break point at C, so it is not continuous at C. Similarly, a function may have break point at more than one point, at finite number of points or infinite number of points. So this is a rough definition. Now consider practical problem. You know y equals to mod x. So we have already discussed in chapter of graph. So graph is like this. Y equals to x greater than equals to 0. So y equals to x greater than equals to 0. That is why this restriction. It may be extended, but it is fixed at this. And minus x less than equals to 0. So this part. So this is graph of y equals to mod x. So y equals to mod x is continuous graph. So look, a function will have discontinuity at the restricted point. So you have to check the discontinuity or continuity at x equals to 0. At x equals to 0, it has no break point. So it is practical example. Now look, you know graph of, I have already discussed it, pi, 2 pi. So sine curve. For sine pi by 2, this is 1. and minus pi by 2. So 3 pi by 2 it is minus 1. So this is 0, this is pi, and it will continue like this. You know this is 3 pi, it will continue like this. Y equals to sin x. So it is practical problem of continuous function. From graph you can conclude it whether it is continuous or not. Now this is, look at the graph. We have already discussed it in the chapter of discussing graph of function, signum function. Signum y equals to signum function. So it is 1 for x greater than 0, it is 0 for x equals to 0, it is minus 1 for x less than 0. Or we can try to recall x by mod x not equals to 0, equals to 0, x equals to 0. So this is graph of signum function. Now, definition of signum function. So y equals to 1, y equals to 1 for x greater than 0. So 0 is not included. It will come very nearer to 0, but not at x equals to 0. We use this symbol. So this is y equals to 1 for x greater than 0. So this is 0, 1. So y equals to minus 1 for x less than 0. So look, it has contribution for y equals to minus 1 for x less than 0, this part not. And at x equals to 0, it is 0. So look, the graph, this one, then this point, then this one. So obviously it has a break point. And you see the restriction on x equals to 0. So it is not continuous. It is not continuous at x equals to 0. So these are the practical examples. So I have already discussed different type of graph in previous videos. Now theoretical approach. Now I have already discussed it is totally based on limit. So let us recapitulate the theory of limit. So look, we have already discussed about the chapter, so try to understand the facts. So right hand limit, left hand limit. So you know, try to recall limit x tends to a plus fx. Limiting value of fx when x tends to a plus. It is denoted by, it is called a right hand limit, and it is denoted by f a plus or f a plus 0, f a plus 0. This symbol. Values of a greater, nearer to a but greater than this. So similarly, limit x tends to a minus fx. It is called left hand limit. So it is denoted by f a minus. Very nearer to a but less than a. So this is left hand limit. Now limit of function exists if LHL equals to RHL and common value is denoted by limit x tends to a fx. If left hand limit equals to right hand limit, we say limit exists and common value is denoted by fa. Now you know fa is, what is the difference? It is value of fx very nearer to a, and what is fa? fa is functional value at x equals to a, and this is limiting value. So limit exists if right hand limit equals to left hand limit. So we need this idea: what is right hand limit, what is left hand limit, existence of limit. Now definition of continuity, theoretical approach. So definition of continuity. So definition of continuity at a point. Definition of continuity at a point. A function fx is said to be continuous at x equals to a if left hand limit, this is denoted by limit x tends to a minus fx, equals to right hand limit equals to functional value. So left hand limit equals to right hand limit equals to functional value. So all are same. So this is x equals to a, right hand limit and left hand limit, they all coincides. Or you know, if left hand limit equals to right hand limit, then we can write it as limit x tends to a fx equals to fa. So this one. So they are equivalent definition. Right hand limit equals to left hand limit, so it is denoted by limit x tends to a fx, and limiting value equals to functional value. So this is our tool. Now to solve, so look, actually it is based on limit. To solve problem of continuity, we should know the standard result of limit. All of you know it, try to recall. So standard limit x tends to a, x to the power n minus a to the power n, n into a to the power n minus 1. Today I will discuss only basic problems, only the board problem. So number 2, limit x tends to 0, sin x by x equals to 1. You know, here x is measured in radian. If it is in degree, then you have to change it radian. The limit x tends to 0, e to the power x minus 1 by x equals to 1. Number 4, limit x tends to 0, e to the power x minus 1 by x equals to log a base e. Limit x tends to 0, log 1 plus x whole divided by x equals to 1. And this one is equivalent if we limit x tends to 0, 1 plus x. This is 1 by x, so it will be at the power. So equals to e to the power 1. So we need these standard results of limit. And you know, there are also several methods of finding limit. Number 1, method of factorization. Number 2, method of rationalization. And number 3, how to find limit when limit tends to infinity. So these are our basic ideas. Now, using this definition and idea of limit, we solve some simple problems of continuity. Now we consider some simplest problem. So fx equals to 1 minus cos x by x square, x not equals to 0, half x equals to 0. So verify continuity at x equals to 0. So try to recall, definition is right hand limit equals to left hand limit equals to functional value, or this is equivalent to limit x tends to a fx equals to fa, this one. Now, when condition is imposed not equals to 0, we use the alternative one. X tends to a means x not equals to a. So not equals to a, not equals to a, then not equals to 0, that is a is replaced by 0. We use alternative definition. So what is our main aim? To find functional value at the specified point and limiting value at the specified point. If they are same, then the function is continuous. So problem number 1. So a is replaced by 0. So what is functional value? So these are 1 marks or 2 marks problem. So f0 equals to half. Because at x equals to 0, it is given half. Now what is limiting value? Now limit x tends to 0, 1 minus cos x by x square. So x tends to 0, it is trigonometric limit. So our main aim will be, so if you put x equals to 0, 1 minus 1, 0 by 0 form. So you cannot put x equals to 0 directly. So we have to use trigonometric limit. So sin x by x equals to 1. So use formula. This is 2 sin square x by 2 by x square. Now 2 is outside because it is constant, and standard limit is, if it is x by 2, then it is x by 2. So try to recall x square. So 2 outside, sin square x by 2 is balance, x square is balance. Now these two will be at the numerator. So to make it balance, it is 1 by 2 square. So this is basic problem of limit. So 2 into 1 by 4, this is 1. 2 into 1 square into 1 by 4. So this is half. So what is limiting value? Limiting value is half. Therefore f0 equals to limit x tends to 0 fx. So fx is continuous at x equals to 0. So 100% application of limit. You know definition of continuity and use limit. Now listen. Some student solve it in this way. So look, it is 0 by 0 form. So L'Hospital rule, I have already discussed it. So if it is 0 by 0 form, then take derivative of the numerator. So 1 is 0, so minus cos x. So derivative of 1 is 0, minus cos x. Cos x is minus sin x, minus minus plus. So half into limit x tends to 0 sin x by x. So half. But remember it, you always use this result in competitive exam, but it is not applicable in case of board syllabus. If it is MCQ problem, then no harm. You can use L'Hospital rule also. But for board problems, if it is not MCQ, then you have to use standard result. L'Hospital is not applicable. Next, problem number 2. So look, here also condition is imposed on x equals to 0. So what is f0? f0 equals to 7. f0 function is 7. Now what is limiting value? Limit x tends to 0 fx equals to limit x tends to 0. What is fx? E to the power x minus 1 log 1 plus 2x. Now try to recall. It is not equals to 0 condition, that is why we are using the second definition. Now try to recall the standard result. E to the power x minus 1, if it is by x, then you get a standard result. Log 1 plus 2x. So log 1 plus x by x is 1. So by fundamental limit theorem, you can take limit of the numerator, limit of the denominator. Look, dividing by x. So meaning remaining same. Now what is the value of the numerator? 1. Now second one is log 1 plus 2x. 1 plus x by x. X is replaced by 2x. So make it balance by 2. So this is half, because it is 1 half. So f0 not equals to limit x tends to 0 fx. So function is not continuous at x equals to 0. So very simple, only application of limit. Next, you complete this one. Now problem number 4. Problem number 4. So fx equals to this, x not equals to 3 and equals to 1 at x equals to 0. So it is condition is imposed on x equals to 3. So what is f3? f3 equals to 1. Now what is limiting value? Limiting value, limit x tends to 0. X square fx equals to limit x tends to 0. X square minus 5x plus 6, correct it, plus 6 by x minus 3. This is x tends to 3 because point is 3. Now you know, if you put x equals to 3, 9 plus 6, 15 minus 15. So 0 by 0 form. So you cannot use x equals to 3 directly. So use factorization method. So if you factorize it, x minus 3, this is x minus 2. And this also x minus 3. So finally, x not equals to 3, so x minus 3 is cancelled out. So x minus 2, so 3 minus 2 equals to 1. So what is f3? f3 equals to 1. So f3 equals to limit x tends to 3 fx equals to 1. So they are same, therefore fx is continuous at x equals to 3. So these are basic problems. Now we consider some more problems, same type of problems. Now problem number 5. Fx equals to 2 into mod x plus x square by x, x not equals to 0, equals to 0 at x equals to 0. So I have already stated, if it is given not equals to and equal to, then we find fa and limit x tends to a fx. But look, for this problem, mod x, so mod x is defined for greater than 0 and less than 0. That is why we use this definition. Right hand limit equals to left hand limit equals to functional value. Because mod x, for greater than 0 it is x and less than 0 it is minus x. So what is functional value? 5. f0 equals to, what is f0? f0 equals to 0. So we are getting functional value at 0. Now right hand limit equals to limit x tends to 0 plus fx. So 0 plus means x not equals to 0. So if x not equals to 0, so this is our definition. Now, you know from definition of modulus function, for greater than 0, mod x is x. So 2x plus x square by x. So limit x tends to 0 plus. So 2 common, x common. 2 plus x by x. If it is x tends to 0, then in limit our main aim will be to cancel x. If x tends to pi by 2, then our main aim will be to cancel pi by 2 minus x. So x cancel, put x equals to 0. So 2 plus 0 equals to 2. So right hand limit is 2. Now no need of finding left hand limit, because right hand limit is 2 and functional value is f0. So RHL not equals to f0. So fx is not continuous at x equals to 0. So no need of calculating here left hand limit, because right hand limit not equals to functional value. So similarly, B exactly same. Exactly same. Now consider 6 and 7. Look, they are of same type. They are 1 marks problem or 2 marks problem. So today we are considering only the basic ones. So problem of both. So fx equals to this, x not equals to 1 equals to 1k. Find k if fx is continuous at x equals to 0. So it is given that fx is continuous at x equals to 1. So not 0, so modify it. Since fx is continuous at x equals to 1, so what is our definition? Limiting value equals to functional value. Now limit x tends to 1. So what is x tends to 1 means x not equals to 1. What is f1? f1 is k. So look, f1 equals to k. Now it is very simple problem of limit by factorization method. So factorize, this is x minus 1, x minus 2. So x minus 1 is cancelled. X tends to 1. So this is our main aim. Sorry, f1 equals to k, not 1. f1 equals to k. So limit x tends to 1, x minus 2 equals to k. So 1 minus 2 equals to k. So k equals to minus 1. Only 1 marks problem. 1 mark problem. So finally, problem number 7. So exactly same problem. Fx equals to k cos x by pi minus 2x, x not equals to pi by 2, and equals to 3 at x equals to pi by 2. Find k if it is continuous at x equals to pi by 2. So modify it. So exactly same. So we use definition at x equals to pi by 2. So since fx is continuous at x equals to pi by 2, limit x tends to pi by 2 equals to f pi by 2. This comes from definition of continuity. Now x tends to pi by 2, that is x not equals to pi by 2. So put the value of fx. K cos x by pi minus 2x. What is f pi by 2? This is 3. Now, if it is board problem, then you cannot use L'Hospital rule. So you have to use standard result of limit. Now since it is trigonometric limit, standard result is sin x by x1. Because if you put pi by 2, this is 0 by 0. So sin x by x equals to 1 when x tends to 0. So our main aim will be to put this limit in terms of, to convert limit in terms of 0. So what is your rule? Rule is difference of this as another variable. So pi by 2 minus x equals to y, or x minus pi by 2. Then change the limit. As x tends to pi by 2, y tends to 0. So this is our main aim. So this implies you change the variable x in terms of y. Y tends to 0. K cos, what is y? What is x? X is pi by 2 minus y. So x is pi by 2 minus y. So what is pi minus 2x? If we multiply, this is 2y. So pi minus 2x is 2y. Now limit y tends to 0. So look, cos 90 minus theta sin y by 2y equals to 0. So k by 2 is outside limit. So this is our main aim, to convert it in terms of non-trigonometric limit. So k by 2 into 1 equals to 3. This implies k equals to 6. K equals to 6. So this is, what is the value of k? K equals to 6. So these are simple problem, and when condition is not given in terms of x not equals to restricted point. So today, through this video, I have considered only definition, basic concept and simple board problem. So thank you for today.